Unit 1, Part 6. So we're making progress on explaining what it means to say this particular argument is invalid. This particular argument, right, has true premises and a false, true premises and a true conclusion, right? But nonetheless, we say that the truth of the premises doesn't force the truth of this conclusion, right? We're saying that this argument is such that it isn't necessary that if the premises are true, then the conclusion is also true. What do we mean by that when the premises and conclusion are also true? What do we mean when we say that it is, even though the premises and conclusion are all true, nonetheless we say it is possible for the premises to be true and the conclusion to be false? What do we mean by that? Okay, we're making progress on answering that. What we mean by that is that this particular argument, right? Notice it's what we're saying. We're saying that this particular argument is itself invalid, right? This one. Why? Because this argument has an argument form, and that argument form has substitution instances, that is, substitution instances which are counterexamples. This argument is valid because this argument form, because its form, the form of that argument, has counterexamples, that is, has substitution instances of that form where the premises come out true and the conclusion false. That it has such substitution instances is what it means to say that it is possible for the premises of this argument to be true and the conclusion false. That is what it means to say that this argument form, the argument form of this argument, that this argument form has a counterexample, is what it means to say that it's not necessarily the case that the truth of the premises makes the conclusion necessarily true. Okay? So what is a counterexample? Let's supply a counterexample, right? That is a substitution. So substitution instance of this particular argument form. Later in Unit 5, you'll be doing a short truth table method where you'll be looking for a counterexample. You're looking to hone in on a counterexample. It will be assigning truth values to the component sentences or the simple sentences in an attempt to make the premises true and the conclusion false. So, short truth table method, we'll be coming back to this idea of a counterexample. You'll be trying to produce a counterexample to an argument form to show that an argument is invalid. So here's a particular argument. Here's an argument form. Let's find a counterexample to this form. That is, let's find particular sentences for P and Q, right, particular substitution instances for P and Q, which make the premises true and yet make the conclusion false. Okay, so here, let's have P substitute for P, the particular sentence, it's raining, and for Q, I'm carrying an umbrella. Okay, and have it be that I'm a freak and I carry an umbrella every day. So every single day I carry an umbrella, whether it's raining or whether it's sunny, and have it be sunny. Okay, in that world, in those conditions, right, if it's raining, then I'm carrying an umbrella is true. I've made the first sentence true. Right? Conditions of making a counterexample are make all the premises true and make the conclusion false. Okay, the first sentence is true because if it's raining, I'm carrying an umbrella. I carry an umbrella every day, so yes, that's true. Right? If it's raining, I'm carrying an umbrella. I'm carrying an umbrella. That's true. I am carrying an umbrella. But it is raining is false because it's a sunny day. I'm carrying an umbrella on a sunny day. Right? The premise is true and the conclusion is false. Right? So that's substitution instances. Those values for P and Q, right? Those particular sentences subbed into P or Q for that argument gives an instance of this argument form which makes the premises true and the conclusion false. Okay, be very clear about what we've shown, right? The mistake I was gesturing at the end of the last part, into part 5, was you are mistaken if you say, well, this particular argument is valid, right? In this particular instance, because the premise is true and the conclusion is also true. But the argument, it's the argument form of that. The form of that argument does have other instances which are invalid. Wrong. Notice what we've done. The judgment of invalidity attaches to this particular argument and every argument of this form, right? An argument is valid if and only if its form is valid, and its form is valid if and only if it has no counterexamples, right? That's the big paragraph from 11 that I pointed at. Like, crucial thing, read it as many times as it takes to have it hammered into your brain, right? So the existence of a counterexample to this to the argument form shows that this, the judgment is this particular meaningful concrete argument is itself invalid, right? So the existence of the counterexample to this form, right? The form of this shows that every instance of this form is invalid. Because even though you've got instances with true premises and a false conclusion, you don't have the necessity, right? So it's through the idea of form that we explicate those modal notions in the definition of form. That's what I started off quoting from 9. What can it mean to say that in the second example it is possible for the premises to be true and the conclusion false, when in fact the conclusion is true? Next paragraph, the answer lies in the concept of form. And the form, the answer lies in the concept of form. If the form has a counterexample, then every instance of that form is invalid. Okay, compare this one here. So this argument we said was valid, even though the premises are false, and the conclusion is false. Dan is made of cheese, then Dan is American. Dan is made of cheese, therefore Dan is American. Here you've got an if-then statement again for this, but here it's also if P then Q, but the second premise over here was the consequent of the conditional. This is if P then Q, Q then P, but this is if P then Q, P then Q. Here, the second premise is in fact the antecedent. Over here, the second premise is the consequent of the conditional. That's the first premise. Over here, the second premise is the antecedent of the conditional. That is the first premise. And here, the conclusion is in fact the consequent. So this is the argument form here is if P then Q and P then Q. Is this a valid argument form? Think about what it's saying. It's saying, I'm giving you two things as true. Remember, validity, it's about whether the conclusion follows of necessity from the premises, and you are to treat the premises as given as true and ask whether their truth implies the truth of the conclusion. And here they clearly do, just from the meaning of the words, right? What am I telling you is true? I'm telling you that if P, then Q. The second thing I'm telling you is that P is true. So if P, and if P, then Q, for sure Q, right? This is a valid argument form, right? This form has no counter examples, right? Has no instances. There are no substitution instances for P and Q that make the premises true and the conclusion false, okay? How do we prove that? Well, we'll only be able to prove that. Remember, P and Q are sentential variables. They take as substitution instances any English sentences, and there are an infinite number of English sentences, so there are an infinite number of possible substitution instances, infinite number of substitution instances of this form. How can I be sure that none of them have true premises and a false conclusion? Well, for that, we're going to need the notion of truth functionality, and we're going to need to learn how to do truth tables, and we will not be able to answer that question and we will not have the resources to show and prove that an argument form cannot have any, we will not be able to show of an argument form that it actually has no counterexamples until Unit 5, until the truth table test for the validity of an argument. Now, right, we can show an argument invalid, right? We can produce a counterexample, right? One counterexample means that every argument, right, one counterexample, that's a substitution instance of a form, one counterexample proves that an argument form is invalid and thus proves that every instance of that form is also invalid, right? So we can prove that an argument is invalid by abstracting its form and producing a counterexample to that form. But it's much harder to prove an argument is valid, that there are no counterexamples. That I want to get to in Unit 5.